Hi everybody, my name is Mrs. Holderfield. Today we are doing lesson 4.8 and it is covering functions. So we're going to start by looking at some vocabulary. So some important vocabulary that we need to have memorized. So the first thing that we're going to talk about is, this is lesson 4.8, functions. So the first word is relationship. Or sorry, not relationship, just relation. So a relation is any set of ordered pairs. Any set of ordered pairs. The next piece of vocabulary that we need to know is called function notation, and this is probably not as important of a vocabulary word as it is a symbol. So function notation. Function notation would say that we take our linear equation y equals 3x minus 4 and we switch this y with our function notation. So the f of x equals 3x minus 4. So we're just replacing the y with this, and this is our function notation. We have a linear function. So linear function, and a linear function would say that we have this f of x, just like we have linear equations, it would be y equals mx plus b. A linear function would be f of x equals mx plus b. So they're still really similar, it's just got a different notation in the front. Something else that we need to discuss is the special properties that a function has. So properties of a function. Properties of a function. And this is true for any function. There is only one output for any given input. So there is only one output for any given input. So the input would be our x values, whereas the output is our f of x values. So the input is our x values, the output is our f of x values. Next, we're going to discuss identifying functions. So we are going to look at how to identify if a relation is a function or not. Identifying functions. So we're going to start by looking at the example. I'm just going to call it A. We have a list of inputs, and remember those are our x values, and we have a list of outputs, so those would be our f of x values. If for our inputs we have the numbers 1, 2, 3, and 4, we plug in 1 to our function and we have an output of 4. We plug 2 into our function and we get an output of 6. We plug 3 into our function and we get an output of 8 or 10. We plug 4 into our function and we get an output of 10. So now we need to determine if this is a function or not. So if we look at our properties of functions, there is only one output for every given input. So we look at 1, there's only one output. We look at 2, there's only one output. When we look at 3, we get 2 different outputs. When we look at 4, there's only one output. So because 3 as an input gave us 2 different outputs, this is not a function. So we would say, because 3 has two different outputs, because 3 has 2 different outputs, this example is not a function. It's very important to make sure that there is only one output for every input. So likewise, if we look at another example, I'm going to call it B. We're going to have the same situation where we have an input-output table. Our input table is going to be 1, 2, 3, 4. When we plug 1 in, we get an output of 5. When we plug 2 in, we get an output of 7. When we plug 3 in, we get an output of 7. And when we plug 4 in, we get an output of 7. So we want to look to identify, is there more than one output for each input? So when we plug in 1, there is one output. When we plug in 2, there is one output. When we plug in 3, there is one output. And when we plug in 4, there is only one output. So we can see that 3 of our inputs had the same output. That doesn't matter. What matters is that each input only had one output. They didn't have multiple outputs like in example A. So this example is a function. That takes us back to that very special property of functions where we would say for every input there is only one output. Next, we are going to talk about evaluating a function. So evaluating a function. Evaluating a function is very similar to evaluating an equation or solving an equation. So if we look at the example, I'm going to call it C, f of x equals negative 4x plus 5. Evaluate when x equals negative 1. So we're going to take our x value and substitute it for, we're going to take our given x value and substitute it in for every x that we see in our function. So this would lead us to getting the f of negative 1 equals negative 4 times negative 1 plus 5. So now we get to perform our order of operations and solve just like we would if we were solving an equation. So we have negative 4 times negative 1 is positive 4 plus 5. So the f of negative 1 equals 4 plus 5, which equals 9. So when we evaluate our function, it's very similar to how we would solve an equation. So we'd get an output of 9. Last for today, we are going to look at graphing a linear function. So graphing linear functions. I want you to look at the example D. F of x equals 3 over 2 times x minus 2. So if we think of our f of x function as just a standard linear equation with the y equals 3 over 2x minus 2, it's going to hopefully it's going to feel a little bit more comfortable for us to graph something that looks familiar to us. So we'd start by making our set of axes. So if we make our axes, we know that it has to go down on the y-axis to -2. So in case we forgot how to identify, this number at the end is our y-intercept. And this coefficient to our x variable is our slope. When you are drawing your graph, don't forget to label your axes, y and x. So y is our vertical, x is our horizontal. We go down to our y-intercept of -2. Next, we are going to look at the slope. So the slope is 3 over 2. I like to think of slope as rise over run. In this case, our rise would be 3 and our run would be 2. You don't have to try to figure out how to count up 1.5 each time. Think of it as go up 3 units and over 2 units. So up 3 to the right 2. We always go to the right. So up 3, 1, 2, 3, there's 3, to the right 2, and we put a dot. If we count again, up 3 to the right 2, we get another dot. From here, we just connect these points that we got. And now we have our function graphed. If you want to label your function, that's not a bad thing. So we'd label it f of x equals 3 over 2x minus 2. You don't necessarily have to label it, but there you go. I hope this was okay. It's probably not as good as Machado's videos. She's pretty hard to live up to, I'm not gonna lie. Have a great day.